Let's discuss question number 9 from test 2. This is from strength of materials. A T-section beam is simply supported and subjected to UDL along its whole span. So you have a beam which is simply supported and you have UDL on the entire span, uniformly distributed load. So the cross section would, so I'm just drawing a bigger cross section. The cross section would be something like this. So T section beam, it will be something like this. Okay, because it's a UDL, so I mean, if you remember the bending moment diagram will be somewhere here, and you will be getting at the center, you will be getting the maximum bending moment of the value WL square by 8. So this is the maximum bending moment. So out of all the cross section, this is the cross section at where your stress will be maximum. Now how do I get the stress because of bending? I need to use bending beam equation. So the bending equation is this: m by I sigma by y. Now let's see what are the terms. M is the moment which is, so this can be applied at any cross section, Now why we are applying at the middle cross section? Because m is maximum, because m again depends on the loading. So we know the maximum bending moment, or the bending moment that is resisted by the beam, is maximum at the center. So when m is maximum, now I and y are again properties of the cross section, but as this cross section is uniform throughout the length of the beam, so I and y will be same. So m is maximum at the center, so I need to apply this. I'll get maximum stress at the center, so that's the logic why I'm applying. Now the sigma is m by y I. Now I is about your neutral axis, which is your centroidal axis, neutral axis, or the centroidal axis. There's a proof which while deriving you will get to notice that neutral axis is the centroidal axis. Now because it's a cross section beam, so here this is your YC. I mean the top layers will have compressive, the bottom layers it's tensile. So the distances, I mean y is the distance from the neutral axis. Now because of the cross section, because it's a T cross section, more area is at the top, so YC is less, YC basically is less compared to YT. So YC is less than YT. Now the same equation if I apply, so sigma compressive will be MYC by I, and whereas sigma tensile, which I'll get at the bottom fibers, it will be M by Y by T. Now M by I is same because M is we are looking at the same cross section, so M will be the total moment that is resisted by the cross section. I is the area moment of inertia about the neutral axis, so I also will be same. So now depending on YC and YT values, my longitudinal stress, whether the compressive stress magnitude is more or tensile stress magnitude is more, that all depends on your individual values of YC and YT. Now we know because of the cross section YC, this because the beam will bend like this, the top fibers will be compressive, the bottom fibers will be in tensile. Because of the cross section, the neutral axis is slightly has to be above because more area is at the top, so this will be slightly above, so YC will be less than YT, and therefore your sigma T will be more than sigma C. So magnitude wise, the bottom fibers will have more stress or more maximum longitudinal stress. So the option is D. Thank you. So all this happens because of your cross section and shift in the neutral axis. Neutral axis is biased towards the top, so bottom fibers feel more stress. Thank you.